Hey everyone, today we're going to do a deep dive on DeepSeek. I'm going to show you why it's not especially innovative. I'm going to show you why it didn't just emerge from anywhere. And we're going to be talking through the US-China tech wars. We're going to be having a look at the hardware stacks that these things actually run on. I'm going to show you why the AI scaling laws have been fundamentally changed forever. And I'm also going to be talking to you about how OpenAI, many months ago, actually started their own journey to scale their own artificial intelligences in pretty much the same way as DeepSeek is actually doing today. And in fact, why OpenAI might very well still be the leader in this space. So let's dig in. Now, DeepSeek is an open source large language model. It's about a 671 billion parameter model, which is relatively small. When you compare the size of that model with, say, GPT-4, which we estimate is a 2 trillion parameter model, and GPT-5 when it comes out, which could very well be a 20 trillion parameter model, then DeepSeek isn't particularly big. However, when you compare it with artificial intelligence models like Chinchilla, it's 12 times bigger. And Chinchilla is important for a reason I'll come on to in a bit. Now, when we have a look at the US-China tech wars, the fact of the matter is that the US doesn't really like China. China certainly doesn't like the US. And China, over the past couple of years, has been spending $1.4 trillion to try to rapidly accelerate the development of its own technology and technology companies. And generally it's working. When we have a look at where China is today in terms of technology development leadership, it leads in 38 out of 44 major emerging technology categories. Now, when we have a look at DeepSeek, DeepSeek was created by a quantitative trading fund. Now, quants are essentially financial services organizations that use artificial intelligence to identify the next best stock picks. We see a huge number of quants in London, a huge number of quants in New York, and so on and so forth. So the company itself is not necessarily particularly special. However, when we have a look at the US-China tech wars, in 2017, during President Trump's first term, one of the first things that he did was introduce tariffs on China. Secondly, he actually banned the export of, shall we say, sensitive products to China. Now, that actually included GPUs. Under the Biden administration, we saw the outright banning of the export of H100 NVIDIA chips. And this is really where China got its mojo going. So firstly, having tariffs against the country, having major export bans against the country, frankly, just pissed China off. President Xi is already very, very familiar with the impact that technology can have on the prosperity and the future prosperity of a country, which is why China wants to dominate global technology standards, including those in artificial intelligence. And recently, China just published 50 new standards in AI. So, slightly different space, but we can come on to that in a little bit. Now, when you fundamentally ban anyone, any group, from using certain key critical resources, they find another way to do it. So if we have a look at the American tech giants, it's no secret that the American tech giants like Microsoft, xAI, basically from Elon Musk, OpenAI, as well as Meta, and even Oracle, have all been building out gigantic, what they call artificial intelligence factories. And these AI data centers have anywhere between 100,000 to 300,000 NVIDIA H100 GPUs, or between 100 to 200,000 NVIDIA B200 Blackwell GPUs. The American tech giants aren't restrained by hardware or by capital. Over the past 2 years alone in the generative artificial intelligence space, we've seen over $600 billion pouring into it. When we have a look at Oracle, Oracle was one of the first companies in the world to announce the full deployment and release of a Zeta scale artificial intelligence data center. So when you have a look at the American tech giants, they don't have to innovate in a vacuum. Now compare that to China. Chinese tech companies were banned from using H100 GPUs. So the typical AI factory in China is lucky if it has 10,000 GPUs. And a lot of the GPUs that the Chinese research organizations have been scavenging have literally come from GPUs in healthcare machines and gaming machines. So scarcity meant that if China wanted to compete with American companies for artificial intelligence domination, they had to fundamentally find new ways to build models, train models, and so on and so forth. And this is what they did. So firstly, they use small amounts of GPUs. This is why DeepSeek only cost $5.9 million to develop. Secondly, in a breakthrough no one has actually reported on, they managed to find a way to train generative artificial intelligence models, large language models, over distributed data centers. If you consider what we're doing in America you have one gigantic data center, you put all the information into there, you train all your models basically on the information in that single data center, and then you're off to Camptown races. With China, they've had to find new ways to do distributed artificial intelligence model training. That in itself is a breakthrough. In addition to that, a little while ago, so over the past 2 to 3 years, I've been talking about the development, even by OpenAI, of what we call small language models. So we've got large language models, which might have, say, 2 trillion parameters, and we've got small language models, which might have, say, 50 billion parameters. They're kind of fundamentally different, but when you actually have a look at some of the performances have been quite interesting. So Stanford, about 2 years ago, announced that they'd built a ChatGPT clone for $600. So what's going on here? Now, when we have a look at artificial intelligence scaling laws, we're breaking them. So I'm going to dig into that. Now, the traditional view of creating increasingly sophisticated and capable AI models as we head towards artificial general intelligence in 2027, 2028, is that you need 3 things. You need to scale compute, you need to scale data, and you need to scale the size of the artificial intelligence models. If you can scale all of those 3 things at a similar rate, then you end up generally with an artificial intelligence model tomorrow that is much better than the one yesterday. However, over the past year, and really it's longer than that, but specifically over the past year, we've seen more and more organizations talking about artificial intelligence development plateauing. We've seen this with Anthropic, we've seen this with OpenAI, we've seen it with Microsoft, and so on and so forth. So how do we fundamentally break artificial intelligence scaling laws to push beyond plateauing AIs that are increasingly uneconomical to build and develop? So when we have a look at the money involved in these things, ChatGPT cost $200 million to train. Anthropic CEO Dario believes that AI models that are being developed today, like GPT-5, are costing $1 billion to train. And in fact, Dario even went so far and said that by the end of the decade, AI models basically might be so complex and so big and require so much compute and so on and so forth, they might cost $100 billion to train. So when we look at breaking AI scaling laws, we add in a 4th element. And the 4th element, as it turns out, is time. Now, you might think time is something that's slightly odd to add into an artificial intelligence, but let me explain. So, if I ask you a question as a human, if you blurt out the answer, just reactionary, your answer might be stupid. It's not going to be the best answer you can give. However, if I said to you, this is my question, think about the answer before you give me the answer, the quality of your answer, the quality of your output is going to be much, much higher. And this is exactly what we're doing with artificial intelligences. Researchers around the world have found that when you give an artificial intelligence time to think about the answer, the model outputs are staggering. Now, we know time better as chain of thought reasoning. So OpenAI a little while ago with their Mini O1 model added reasoning and chain of thought reasoning into their models. When we have a look at Chinchilla, remember I mentioned Chinchilla? Chinchilla is an American 50 billion parameter artificial intelligence where chain of thought reasoning was used, and it beat models that were 6 times its size. So is this now starting to sound familiar? When you go and have a look at all the research and all the deep dives on DeepSeek, people say, the reason we think this model is so good is because it uses chain of thought reasoning. Chain of thought reasoning is not new. If anything, it was first established in the United States. So now when we start having a look at China, DeepSeek is a 671 billion parameter model that uses chain of thought reasoning, which actually means that it's not that efficient when you compare it to something like Chinchilla or even Llama 3. It's using a small number of GPUs. I don't know if it was trained over a distributed GPU data set either. But as we start looking at the future of Chinese artificial intelligence, is now consider this. China has managed to upset the AI apple cart because it's managed to develop some very, very good artificial intelligence models with a scarcity of resources. So now let's bring in Huawei. Huawei over the past couple of years has been building a multi-billion-dollar campus. We have organizations in China that are trying to replicate and beat ASML's sort of photolithography machines. These are the machines you use to create sort of small transistors, much, much faster processors and everything else. In addition to that, you've got Huawei and others that are now starting to develop GPUs that many actually regard as being almost as performant as the H100 GPUs. So if China has managed to get this far with a scarcity of GPUs and so on and so forth, now imagine what happens basically when they have the abundance of the American tech giants. They accelerate. They go much further, much faster than anything that we're going to see in the West. So when we have a look at DeepSeek, it's not new. It's not innovative. And actually, it definitely is not the last time that we're going to see an artificial intelligence company upset the apple cart. And if you'd like to hear one more thing that OpenAI has been doing that no one else has been doing, then let's quickly round out with this little piece of gossip. OpenAI, about 8 months ago, when they were developing the precursor to GPT-4, developed an artificial intelligence that bootstrapped its own artificial intelligence, or its own intelligence. The way that it did this is OpenAI trained their AI model, their large language model, on lots and lots of data. The AI learned from that training set and created some decent outputs, etc., that have actually gone on to beat the AGI benchmarks. However, OpenAI then instructed the artificial intelligence to make its own synthetic data sets. It did that, then it started learning from those synthetic data sets. So we have already passed the point where artificial intelligences are now bootstrapping their own intelligence and intelligence capability. So what happens when we start putting that on steroids? And with that, I will leave you to ponder the vagaries of US-China tech wars, American tech bros, the weirdness of the tech bubble, the importance of hardware, and how the world perhaps is not actually what you thought it was 10 to 15 minutes ago. Thank you very much for listening. Take care. Stay tuned for more news. Goodbye.